Hi there, you're in the lab with your mate JJ. So today I'm going to start a new feature of the video blog. This is to go with the other features that I already have. So the main channel is obviously in the lab with JJ, and I do electronics projects from time to time. And when I do one, I introduce an old book and a new book, and have those as features of the show. But what I'm going to do, starting with this video, is just some interlude videos that stand off to one side from that, wherein I work through my Maxitronics project kits. I've got a bunch of them. They start with the 10-in-1, which is a very entry-level sort of thing, and then it goes through 30-in-1, 60-in-1, 130-in-1, 200-in-1, 300-in-1, and then 500-in-1, so they get progressively more sophisticated. I'm going to start at the beginning, and this is the first video, so this will be project 1 of the 10-in-1, and this is it. This is what it looks like. The 10-in-1 Electronic Project Lab. Safe, solderless, exciting, educational, and fun. Easy to read, illustrated operating manual included, all in one, 10 electronic project experiments. So it's from Maxitronics. It got sold over the years under various brands. I have the full set of Maxitronic ones, I believe. And I have some of the other stuff that came out around the same time from Maxitronics, and I thought I'd just show you that quickly. I've got the electronic metal detector, which is a standalone project. I have two of these electronic AM/FM radio kits. I've got two, they're the same. So that's just to make an AM radio and to make an FM radio. And then I've got this one, which is the electronic crystal radio kit. So it's to make a crystal radio. And then there's this guy, the Sensor Robot 20, Action Science Electronic Project Lab. So it's I guess you could call it the 20-in-1, but that isn't specifically how it's branded. So I'm going to start with the 10-in-1. Now, if you're an experienced electronics person, this will be quite boring for you, but I like doing the simple and fun things. So I'm just going to work my way through from the beginning. So I'll just do the very basic circuit. The circuits will be made over here in the booth. The booth has a little standoff. You can't see from that angle, but there's an area there for me to show you the book. If we pop this out of the box, you'll see that it comes with an owner's manual, as well as the kit itself. So we'll put that over there in the booth. We'll go through the manual and we'll do the first project. After the project's done, we're going to take the equipment over to the bench. We're going to power up the scope and we're just going to poke about it and have a look at it. There's basically going to be 3 parts to each of these videos. The first part will be the introduction, telling you about what we're going to do. The second part will be assembling the project over in the booth. And then the third part will be bringing it over to the bench and putting it under the oscilloscope and just having a poke about to see what we can see. So the first project that we'll be doing from the owner's manual here is, there we go. This one's called Morse Code by Light. So that's going to be the first project. Here it is. So it's just a one-pager. It's called Morse Code by Light. I'll give you the full list of projects. There's only 10 of them. So the first project is Morse Code by Light. The second project is Morse Code Oscillator. The third project is Diode Experiment. The fourth project is Diode Radio. The fifth project is One Transistor Radio. The sixth project is One Transistor Radio with Diode. The seventh project is Wireless CW Transmitter. The eighth project is Patrol Car Siren. The ninth project is Audio Frequency Oscillator. And the 10th project is Burglar Alarm. So these are just silly little projects. They shouldn't take very long to do. There's probably not that much to look at, but we'll stick them under the scope and see what we can see. And it should be a little bit of fun. And after we've done the 10, we can proceed on to the 20, and it'll get progressively more interesting. There's actually I've got one up there called the Electronic Digital Recording Laboratory, which is also a bit separate to the XM1. And this particular one, it has about 50 projects in it. So if you'd like to see any of these special ones, let me know, and I can do a special thing. But I'm just going to start with the XM1s, and we're going to start with the 10-in-1, and we're going to work through that beginning today. And yeah, that should be fun, and I'm looking forward to it. So I'm going to pop you over to the booth. We'll put the thing together, and then we'll come back and we'll have a look at it in the lab. All right. Well, here we are in the booth. This is the 10-in-1 Electronic Project Lab. It's got a battery in it. I haven't tested that battery recently, so we'll do that before we begin. But this is basically what we're looking at. Now, I can switch you over here. This I call the book can. We can see here is the circuit. I'm not sure yet exactly how we're going to go about all of this. I might just throw you back over here for a minute, and I'll just put him away, and perhaps we can have a look together at the instruction manual. So this is the owner's manual of the 10-in-1 electronic project lab. Safe, solderless, exciting, educational and fun. Easy to read, illustrated operating manual included, all in one, 10 electronic project experiments. A great introduction to the world of advanced electronics. Spring coil connection to make it safe and easy for operation. Learn and build 10 exciting electronic experiments safely and easily. Quick, easy and safe to learn the basics of electronics, no tools or soldering required. Learn as you perform 10 exciting experiments involving Morse code, burglar alarm and radio. And this is from Maxitronics Enterprise Limited in Taipei, Taiwan. The experiments in this kit are designed to comply with FCC rules as long as you follow the instructions and use only the components and materials supplied with this kit. Copyright 2001, printed in China. There you go. Now, I suppose we might as well go through the introductory material. This is number MX802, 10-in-1 Electronic Project Lab. The 10 projects in this versatile 10-in-1 electronic project kit contain the very exciting fields of electricity and electronics. This manual describes 10 different projects you can build with this kit. You don't need special skill or equipment. You can easily build the electronic circuits for all 10 projects without tool or soldering. All of these interesting projects, which have been designed to acquaint you with basic electronic theory, really work. The circuits include radio receivers, Morse code oscillators, and continuous wave transmitter, and audio oscillator applications such as a burglar alarm and a patrol siren, etc. After you've experimented with the circuits described in this manual, you will find other applications for the same basic components. The more you learn from this kit, the more you will be able to do. Get ready for many hours of fun. You will find the world of electronics fascinating and rewarding. And then there's a list of projects, which we've already been through, but I might as well do it again. The list of projects is Project 1, Morse code by light. That's the project that we'll be doing today. Project 2, Morse code oscillator. Project 3, diode experiment. Project 4, diode radio. Project 5, 1 transistor radio. Project 6, 1 transistor radio with diode. Project 7, wireless CW transmitter. Project 8, patrol car siren. Project 9, audio frequency oscillator. And Project 10 is a burglar alarm. The parts used in this kit. This kit contains up-to-date solid-state electronic parts, including a transistor, diode, variable, that is tuning, capacitor, bar antenna, iron core choke, a coil, earphone, code key, resistors, and capacitors. These parts are described below for your information. Bar antenna. The bar antenna consists of a ferrite core around which a coil of wire is wound. The antenna coil is used with the variable capacitor, VC, for tuning, RF, radio frequency, signals. Transistor. The transistor contains 3 elements, base, B, emitter, E, and collector, C, in which current can be made to flow. The transistor in this kit is an NPN type, which is used to amplify current. Diode. The diode used in this kit is a germanium type that is used as a detector in radio receivers. One of the projects in this kit demonstrates how a diode operates. Capacitor. Capacitors consist of 2 conducting plates separated by an insulating plate made by an insulating material. Capacitors are used to store electrical charges. The capacitors used in this kit are rated in microfarads and picofarads. Resistor. Resistors are made of material that resists current flow. Resistors in this kit are rated in kiloohms, K, meaning thousands of ohms. Earphone. Earphones change electrical energy of audio frequency into sound. The earphone in this kit is a high impedance, that is high resistance, crystal type. Low impedance type earphones will not work in these projects. Transformer. A transformer consists of 1 or more coils wound on an iron core. It is used in this kit to develop audio voltages from the audio current supplied by the transistor. Key. The key is actually a switch, which is closed when it is pressed down. Keys are used to turn on or turn off audio tones or RF signals smoothly when transmitting Morse code, dots and dashes that represent letters and numbers. The international Morse code is shown at the last stage of this manual. How to use this kit. There are 10 projects in this kit that can be constructed one at a time. To construct any project, pull out the kit on a flat surface where you have room to put the projects together. Now use the pieces of hookup wires supplied with this kit to wire up the particular project you want to construct, following the heavy black lines shown on the corresponding wiring diagrams for that project. See the wiring instructions below. Attach the 9-volt battery clip to a fresh 9-volt battery, 006P, VS332 or equal, not supplied. Then push the battery into the battery holder mounted on the paper panel. Important. To conserve battery power, remove the clip from the 9-volt battery when it is not being used. Wiring instructions. Most of the parts in this kit are mounted on the paper panel, and their leads, wires, are connected to the spring terminals under the paper panel. The hookup wires in this kit are supplied in different lengths to fit between different spring terminals. Be sure to follow the printed heavy black wire connections carefully and correctly. To connect a wire to a spring terminal on this kit, first bend the spring to the side and insert the bare end of the wire into the spring and bend it around to make a good contact, then release the spring. The bare wire must be tightly connected against the spring. If you have to attach a second wire to the same spring, bend the spring to the opposite direction when inserting the second wire. This way the first wire won't fall out and remains in good contact. An earphone is provided in this kit. If the circuit calls for an earphone, simply connect the two ends of the earphone to the earphone terminals. A long length of wire is included in this kit for use as an antenna. When an antenna is required, connect one end of this wire to the antenna terminal and spread out the wire for best reception. If a ground connection is required, cut off a piece of wire and connect it between the ground terminal and a cold water metal pipe. Be sure to scrape off any paint or dirt from the ground metal pipe before wrapping around 6 inches of bare wire around it. Okay, well here we are. Circuit descriptions. 10 projects you can build with this kit are described in this manual. A schematic diagram, electrical blueprint, is shown for each circuit, and useful information is provided to help you learn the basic knowledge of the electronics. Circuit number 1, Morse code by light. This simple series circuit will let you practice or transmit Morse code not by sound but by light. The lamp will light whenever the key is pressed down. Using 2 kits, you and your friend can communicate with each other without any wired connections. Just position the lamps where they can be seen by each other. It is even easier to transmit and receive in the dark. You can use the International Morse code printed on the last page of this manual. The wiring checklist is connecting 24 to 26, 27 to 28, 25 to 29. So this is about as basic as it can get as a starting point. We've basically got a battery, a lamp, and a key. So in order to get started, let's just check the status of our battery. I've got a battery tester, so I'll do that. Here's the battery tester. Now, oh look, that's in bad shape, that battery. Yeah, dead as a doornail, and it's done some damage to the terminal. It's been sitting there and rotting. So I'll go digging for a fresh battery, and I think we'll give that terminal a bit of a clean. If I flip you over to the other side, I've got a battery case here, and there's my 9-volt batteries. So I'll just use one of these ones, which is the same type that was in use over here. So this is my isopropyl. Just going to give it a bit of a spray. I'll get some dirty brush as well, I think. So let's hit this guy. Is there much slack there? Not really. Give him a scrub-a-dub-dub. All right. Now I suppose probably wouldn't be a bad idea to test the new battery as well, just to make sure that it's functional. Yep, this battery's in good condition. I'll just put my batteries away. There's our new battery there, plugging in a second. Let's get rid of this stuff. Alright, how are we doing? So, there we go. I suppose it wouldn't hurt to just quickly test that the connection is sound. So, let's just take our multimeter and we'll put him on voltage. There's voltage. Can you see that? And we've got common and positive, and then we've got positive and negative, and we're reading 9 volts. Great. So the battery seems to be working, which is what we want to see. So I'll just switch you back over to the circuit diagram. So we're looking at a battery, a 9-volt battery running into a lamp, and a lamp running into a key, and it's as simple as that. So it's only it's only 3 wires. I'm putting back over here. Now the instructions say connect 24 to 26. So we've got 24 here, it's one side of the lamp, and we've got 26 here, which is the positive power rail. Now I've got a bunch of wires. The wires are of different lengths. This length, the lengths are color coded. So the blue wire is the one that's the appropriate length for this one, I think. I wonder if we could do red. Red's the next size down. It'll fit just. I actually like having a bit of slack in there, so let's stick with blue, and that gives us plenty of slack. So we connect spring terminal 26 to spring terminal 24. I remember when I was a kid and I was doing this, I was so excited by this stuff, I thought it was the bee's knees. So this is 27 to 28, which is a very short one. So the short ones are white, so that will do here. That's the negative power rail over to the key, just one end of the key. And of course the key is not polarized, so it can go either way around. In fact, this whole circuit's not polarized because the lamp isn't either. So there's nothing that actually requires a positive or a negative connection. So the final thing is just to jump 25 to 29, which we can do with the white wire as well. So we'll put that in there, and then we'll put him in there. Now, when we press the switch, the light should come on. So fingers crossed. Yes. Isn't that great? And of course, to use it for Morse code, we need to that's the only Morse code I know. It's SOS. SOS. Now, I did say that we'd take our circuit and we'd analyze it together underneath the oscilloscope, and we can certainly do that. It's not going to be particularly interesting because the circuit doesn't do much, but it does change state, so we should be able to detect that with the scope. So that concludes the video. Sorry, that concludes the middle part of the video, which is where we actually assemble the circuit. I'll flip you over to the bench and we'll have a look at this thing underneath the scope. All right, well, here we are in the bench. Now, I have to say, on the bench, we use a better computer for doing the recording. We actually use the same quality camera, but I'm having trouble getting a high resolution feed on the other computer. So I thought I'd start off with a view of the circuit diagram for the circuit. This is it here. I'm not sure how well it showed up earlier when I was showing it in the booth. This should be a high resolution picture of what we're dealing with. So there it is for your reference. Obviously we've got the 9-volt battery running into the lamp, running into the key, running back into the battery. So that's the circuit, about as simple an electronic circuit as you can get. This is our circuit here. Now, as promised, we've got our oscilloscope to test. So let me just show you that. That's the oscilloscope there. Actually, if you want to see the full scope, it looks like that. But you know, while we're working on the thing, let me just show you there. That's me in the background. That's the scope there, as you can probably deduce. Now, this is our test probe. It's for channel 1 on the scope, which is the yellow line that's fizzing around there at the moment. I'm not sure what would happen if we shorted that out, if it had calmed down or not. Yeah, so anyway, there's just a bit of noise there on the line. So what we'll do, this circuit, there's not much to show you, but we'll put the negative end of the probe on the negative terminal of the bulb, and we'll put the other terminal here, and then we'll hold down the key, and we'll just press auto calibrate. Oh, what happened then? Oh no, I've done something. Oh no, it's working. Just a poor mechanical connection there. Okay, good. So while that's on, we'll just hit auto, and it should tune itself. There we go. And if we drop it, we'll see that the signal goes between high and low. Let's go back, and how do we menu off? Okay, so we're going to just take the menu away there. Now, this thing doesn't seem to have a scale on it, so we know it's high and low, but we're not seeing a scale. So let's see if we can turn on display and then show scale. There we go, wonderful. So that was easy. So obviously at 0 volts there, and then up to, well, I guess it's up to 9 volts, isn't it? It's just a bit above 8.16 volts on the scale, and it drops down to, well, I guess that's 0. Okay, so yeah, I wonder if we could, yeah, we can adjust the offset and the thing. So let's just put the offset at 4 negative. Okay. There we go. So that's a nice clean scale there now, as you can see. I can pop you back over and we can have a closer look there at the output. So you can see that's the scale that's being done. So we'll close that. Now if I press the button, it'll jump up to 9 volts. It'd be good if it gave us some reporting. Let's see if we can display other things. Color grade. I don't know what that is. Vector, intensity, grid, brightness. Well, I probably want measure, and then statistics and on. Okay, so we've got statistics on. How come we're not seeing the statistics? Or maybe we are. I'm not seeing statistics. Do you see statistics? Let's go measure statistics on. How do we show the statistics? Maybe back on display, dots, vector, back on measure, or measure, channel 1. Oh, there we go, look at that. So menu off, and let's just move him down to the corner here. Alright, so what are we reading? Okay, voltage average is floating around slightly negative millivolts. RMS. Okay, now if we hold down the thing, Vmax is at 8.4 volts. Yep, okay, great. So the power is delivering between 8.1 volts and 8.4 volts. The standard deviation's about 90 millivolts. Fascinating. So there we go. And of course, all the other stuff's not showing because it's not actually it's not an oscillating signal. So yeah, that's pretty much everything there is to show you about the oscilloscope. Actually, I could just quickly throw you over here, and there you can see the. Oh no, we seem to have lost the. We lost the feed there on the thermal imager. So I can tell you, yeah, actually, it's fascinating. Let's get that working. If you just bear with me for 2 seconds, I'll be back in a second. All right, I'm back. Sorry about that. I just had to reset the thermal imager. So I'm going to pull that up now. And I'll just show it to you on this screen. There's the thermal imager there. That's the thing that you can see there. Now, as you can see, my hands are warm. You can see my warm hands on the image there. And you can see that's my leg in the bottom left-hand corner. And you can see when I press the button, the light goes on and the light gets hot. So you can see the hot part of the circuit is clearly the light. Isn't that fascinating? So it continues to be warm even after we take the key off and it goes back down. So yeah. That was pretty good fun. I guess I'll pop you back over to the other camera and we'll finish up the video. So I thought that went pretty well. What did you think? I mean, the circuit was pretty basic, but look, we've crunched through the introductory material. We've made our first circuit. We've given you an indication of what the format will be. So it'll be in the booth to make the circuit, in the bench to test the circuit with the scope. As the circuits get more complicated, the scope measurements will be more interesting. We learn how to show the measurements on the scope. We manage the offset recalibration. We figured out how to put the scale on. I'm just learning the scope myself, so it's an excellent opportunity for me to learn how to do these basic things. So yeah, I really enjoyed this video. I'm so glad we did it. And look, there's 1,200 more. I think it was 1,283 more projects to come. So look forward to that and see you next time.